Okay, Wednesday afternoon. So on to new things. So we're topic 11 today. So just a reminder, we're 1 week away from midterm 2. So don't forget about that. Topic 11 will be covered on the final, but not midterm 2. Usually I have midterm 2 slightly sooner, but because of it wasn't quite, I think I mentioned I wasn't sure what was going on with that reconciliation. I didn't want to make sure we covered the material, but we're perfectly on schedule, and but we do have to move on. Okay. So topic 11, epidemiology, disease transmission. We're going to talk about a bunch of things, and a lot of the examples that we're going to look at are things that we've talked about already. So that's kind of the good news. But first, let's go through some definitions and a few other things. Let me show you this, right? This is a graph I found. It's kind of harder to find any newer information, but you can see this is top 10 causes of death, high income countries. If you look at the one in red, lower respiratory infections, basically you've got one disease in the top 10 that is infectious, right? So it shows you that we have drugs, we have vaccines, we have good health care, all of those kind of things. Everything else on the list is what we'd call, chronic diseases, lifestyle diseases. We're living long enough to have cancers. We're living long enough to have heart disease and things like that, which are the big killers. Of course, there's not much we can necessarily do. Actually, this is not top causes of deaths. That's misleading. Whoever made this graph, this is top leading of deaths by disease. Because I think number 1 or number 2 in Canada is actually car accidents, believe it or not. So, people are worried about vaccines and things like that, given the money harm. They should probably not get into a car. All of us here have 1 in 100 chance of dying in a car in our lifetime, right? Pretty sad, eh? Anyway, but I want to contrast this with a second graph here. If I can get this going, there we go. If you take a look at low-income countries, right? It's all red or mostly red. You've got tuberculosis, you've got AIDS, you've got diarrheal diseases. People are not usually dying of diarrheal diseases in Canada. This is mostly children under 5 in poor countries, and so on. Malaria, so some of them are geographical kind of things and so on. So like I said, I'm not entirely sure about the data in terms of how accurate it all is, but you get the idea, right? And this is kind of a little bit about what epidemiology is all about. I'll show you some other numbers, and you can collect all sorts of data for all sorts of diseases. And this is a lot about what epidemiology is all about. It's the study of diseases and populations, and you're looking at all sorts of statistics and things like that. It's a science that usually makes use of a lot of statistics because there's a lot of experiments you can't do, right? I can't take half of Canada and expose them to a pathogen and leave the other half as control group. You can't usually do that. So you're often looking at data retrospectively, right? So, you might look at, okay, why is it that there were a lot of cases of West Nile disease in Saskatchewan this year? Right. And so you start correlating that with other data. It could be weather data, it could be mosquito populations data, and trying to look for patterns, right? So you can see my definition here: causes, distribution, effects of disease, and health related, right? So prevention kind of goes hand in hand with that as well. And I'll give you some examples of prevention. Here's some Lyme disease data. So you can see the number of cases seem to be going up, and this is true whether it's the 1990s or current data, doesn't really matter. Got this from a textbook. But here's the other thing that's kind of interesting. And if you don't know anything about Lyme disease, you can take a look at this and you can see there's a pattern, right? A pattern of it's kind of going up around July, August. So, here's where the epidemiologists, if this is a brand new disease, are trying to sort things out. Does this have something to do with ice cream consumption? Does it have something to do with people going to the beach? Probably not, but it could be. It could be a beach disease. So this is where you start looking at the data. Are people getting it at the beach? Right? The answer is no. Where would we get Lyme disease? Ticks. Yeah. So the tick population is going up. So you start looking at correlations. You start looking at the data, and they start, hopefully getting closer to an answer. In this case, we know the answer. And this is what epidemiologists do, right? They're a little bit like detectives sometimes, trying to understand the causes and hopefully come upon some of the right answers. Some of these studies are very long-term, trying to really fully understand things. You can imagine epidemiology of cancer. Cancers often take 20 years to manifest themselves. So you had an exposure 18 years ago, now finally you're getting sick, right? So sometimes those are a little bit long-term and hard to understand. Here's some data from, this was a report that came out in the Edmonton Journal last year. And actually, there's been a few reports like this over the last decade looking at syphilis cases. And this isn't just Alberta, by the way. Syphilis cases are on the increase in Canada in general. And this is not good, right? I mean, particularly like, look at this, 2014 to 2020, like that's a it's like 100, 10 times, 20 times more. This is the kind of thing that public health people, worry about when you see these kind of numbers, right? And generally, right, you don't want to be the syphilis capital of Canada, right? If you're Edmonton, okay, so, that's what you're trying to prevent as well. You don't want that kind of reputation. I'll show you some other information that they had in this report. So it says here about 1/3 of cases were from anonymous partners through dating apps, right? So maybe this is a cultural thing. There's probably some studies behind that. 1/4 of cases among gay and bisexual men. Okay, so this is important information, right? Disproportionate number of cases among Indigenous persons. Okay, again, you've got some information here that may give some information around what the public health response might look like. 50% report injection drug use, 15% amongst pregnant women. And here's the other thing, right, is looking at pregnant women, because syphilis is unfortunately one of those germs that can cross the placenta and lead to miscarriages, right? So, this is, we're hopefully trying to prevent these kind of things. So 30 babies have died since 2015, I guess, probably a couple more now. And 2/3 in the Edmonton area. Like I said, not looking good for Edmonton. I mean, this is a year later, so, who knows what the numbers look like now. Usually it takes almost a year to get the data for 2022, for example, right? So what do they do with this? Any thoughts? So promotions, right? Yeah. So you probably saw the data. Who are you targeting, right? All of those things that are on the list, right? So you're targeting probably Indigenous people, gay and bisexual men, anybody else at risk. So sex workers, college students, those are all populations that may be at risk, right? But generally, that's what you do. Contact tracing. So if you had COVID in the early stages of the pandemic, you probably got a phone call and there were people that were trying to figure out who you were in contact with. And this is important for any outbreak, right? In this case here, it's a little bit easier than COVID because usually it's you're looking at a sexual partner, and most people remember who they're in contact with that way, as opposed to COVID, where it's like, okay, I had the plumber and I went to the grocery store and the gas station and, et cetera, right? And you don't even know their names, right? Frequent prenatal testing, right? So if there's neighborhoods in Edmonton or hospitals that are seeing more cases, you're going to be a little bit more vigilant in making sure the testing is done. And then outreach, like I said, you're looking at all the populations that might be having unprotected sex with new partners and things like that, and anybody that was identified in the study, right, as a higher risk group, right? There was, I think, I can't remember what year that was. There was another thing in the news, and I kid you not, the very next day, walking around the college, I saw this poster, right? So they were targeting college students, right? And so when they were done with the poster, I inherited it. But I think that was about 6 years ago now. And it was, like I said, it was very funny. I saw on the news, and then the very next day, there's posters like this all over the college. So, somebody was doing their job, I guess, right? At least for the college population, right? So this is epidemiology, right? Sometimes you're looking at preventing, we know a lot about syphilis. Sometimes it's new diseases. Sometimes it's long-term stuff we're trying to figure out, particularly when you get to health and and all these chronic diseases that we're trying to tease out causes and preventions and things like that. It can get very complicated. Anytime there's something new, the epidemiologists are always looking at the data and trying to figure out, how and what is going on, right? When HIV first came out, it was mostly initially recognized as something that was hitting gay men. And then it wasn't that long after they realized that other people were getting sick too, and probably had something to do with sex and blood. So one of the big questions that came up very early on was, can this virus be transmitted by a mosquito, right? That's actually a great question. The answer is no. But this is the kind of thing that, epidemiologists were looking at right away to see, how were people getting this? The contact tracing, all the data showed them that it was bodily fluid contact, right? So objectives of epidemiology, all these things we were just talking about. Sometimes identifying causes, sometimes reservoirs. So we'll talk about what a reservoir is very soon. It kind of means the natural place where a disease is living out there, wherever that might be. And some of these things we don't have answers for. Like Ebola, we don't really know what the natural reservoir is. We suspect it's bats, but we're not 100% sure. And spread of disease. And you can throw, prevention and things like that in there too, which are kind of important. Help improve conditions. Thought I had another one on there, reduce occurrence. But like I said, looking at the patterns and all that. So we're not getting deep into epidemiology and all the statistics and all the tools and things like that, but just kind of more or less some definitions. They're going to help us with the language of understanding some of the things we're talking about in this particular unit. But like I said, it's kind of a big discipline involved in public health and health research for many, many things. Okay, so some definitions. Number one, prevalence, right? This is the number of infected people that are at a current time, right? Okay, so like, maybe right now in Fort McMurray, I don't know what the actual number is, but let's say the number is, 800 people are currently ill with COVID-19, let's say, right? So that would be the prevalence. It's the number, right? The other definition that kind of goes hand in hand with this is the incidence, right? So the number of new cases. So maybe there's 100 new cases a week, let's say, and that would be the incidence, right? And so you can see they kind of add together and you'll get the total cases, right? So often these words are used kind of, when they're talking about diseases. Sometimes they might use percentages. They might say 5% of the population is currently infected, or we're getting, maybe they use per 100,000. So they might say, we're looking at 100 new cases in Alberta per 100,000. And that way you can compare two different provinces that have very different populations. So there's lots of different ways to use these kind of words, right? Generally, people getting better through either the immune system or cures are going to change those numbers. And obviously deaths will as well, because it means there's one less person that's sick because they're no longer with us. So some definitions, I'll probably use them a few times. So that's why I'm kind of throwing them out there. So other definitions that are really important to understand are endemic, epidemic, and pandemic. Okay. These words are abused all the time, right? So it's important to really understand what they mean. Notice I threw some maps up there. Has nothing to do with how severe the disease is. It has more or less to do with numbers and geography. And that's what I want to get into. And I'll give you examples of each. So endemic, what does endemic mean? Endemic means kind of the normal situation for a specific place, right? Sometimes you might say, for example, moose are endemic to Alberta, right? That's a proper use of that word, meaning that moose live here, right? Certain diseases are endemic to Alberta. So for example, people get the flu around here, right? That's a normal, natural thing. And usually there's a pattern with something like flu. The cases are kind of starting to increase around November, and they peak around January, February, and they go off. So it's kind of more of a cooler weather kind of disease. There's a few people get sick in the summer. But there's usually a normal pattern, right? I think I have some numbers on one of the next pages here. But some diseases or animals or whatever are not endemic to Alberta. So malaria, for example, is not endemic. It doesn't get transmitted here. It doesn't mean there are not people in Alberta with malaria, but they got it somewhere else, somewhere warmer, where it has the right mosquitoes, and they probably flew here on a plane and they're getting treated here, but they never got the disease. Panda bears are not endemic to Alberta, right? So it's another way to use the word. So there's influenza. So we're kind of expecting somewhere in this order of the number of cases per year annually. It goes up and down, right? When we had all the lockdowns during the pandemic, flu plummeted to record low numbers. But I'm expecting this year will be a little bit more normal. Some years might be closer to 4,000. Some years are a little closer to 2,000. But there's kind of a normal expected range. Malaria was the other example I gave, not endemic to Canada, but endemic to these places, right? Tropical and subtropical areas of the world. And so, if there was, if there was a malaria outbreak in Canada, right? Then we'd use a different word for it. Okay, and that's the next word. The next word is epidemic, right? And there have, believe it or not, been malaria epidemics in Canada. There are certain parts of Canada that have the right mosquito. So parts of southern Ontario, parts of eastern Canada have the right mosquito, just the disease isn't in them. And there was a case, I think it was in the 1800s, there was an outbreak in Peterborough, where I'm guessing someone who was infected came to the right place and the right mosquito bit him or her. And then I think there were a few hundred people that got ill from malaria. So it is possible, right? And that would be an epidemic where you have suddenly, you have an outbreak of new cases, something new, or just more than usual. So what would it say for flu there? 3,000 to 4,000 cases per year. Well, suddenly we had like 8,000 cases of flu. That would be an epidemic, right? So like I said, higher than usual or something new, because something new, you're going from 0 to any number, right? So if we had like one, well, I don't know if we had one case, but if we had one case of Ebola in Canada, I don't know if I'd quite call that epidemic. But if we had a handful of cases, right? So some examples of some epidemics, right? The original SARS epidemic, that was 2002. Okay, this was the first coronavirus, SARS-CoV-1. This was in a few different places, China, Hong Kong, and Toronto, a couple other places, South Korea, I think Singapore had a few cases. Trying to remember how many cases were in Toronto. It was either 43 cases or 43 deaths. This was scary at the time. I remember I was living in Ontario and every hospital in the entire province was locked down. The cases were only in one hospital in Toronto. This was a case where somebody from Hong Kong jumped on a plane and boom, it was in Canada. And Toronto was like a ghost town, right? If you ever go to Toronto, it's a very busy place. People weren't going to anything, any of the baseball games or anything like that. International tourists were told, avoid Canada, all of Canada, even though it was just one city. Tourism Canada plummeted that summer. Lots of interesting stories about that. There was a big concert put on by the Rolling Stones, which is a big part of that to try to bring tourism back. And anyway, lots of interesting stories. But this was an epidemic. It was something new. And so 0 to whatever the numbers were, and found in a few different places. There's been a few Ebola epidemics. Ebola was discovered in 1976. There's actually a more recent one, but this was the big one that was a few years ago now, 5 or 6 years ago now, where we had, I think there were like 15,000 cases. There were even a couple of cases in the US and a couple of cases in Europe. So this was a big deal. That was the first time there had ever been cases in the US, for example, on this side of the ocean, and affected quite a number of people, right? Made a lot of headlines. Not hearing as much about it now, but although I believe there is another outbreak going on in the Democratic Republic of the Congo that we're not hearing about too much because COVID is kind of taking the newses. Zika, there's another one. So you can see it says here it was discovered quite some time ago in Uganda and was only ever found on the African continent until the 2000s, right? and some, I don't know, it looks like it's jumping across the Pacific here somehow. And then what year was that? 2014, roughly, if I remember correctly. It was hitting the Americas, and lots of people asking questions about what was going on, right? So these are epidemics. So what's a pandemic then, right? It's next level. We're talking about everywhere, okay? Or most places, or many geographical locations, right? Spanish flu, the 1918 pandemic, is a classic example of this, right? So the flu profile, I just mentioned a few minutes ago, right? We're looking at cooler weather, often countries like Canada that have seasonal things going on, right? The virus kind of likes it when it spreads a little better, when it's a little drier, a little cooler. So places like Mexico, these islands in the Caribbean and Pacific, they don't get a flu season. There might be 1 or 2 cases a year or whatever. I don't know what the number of cases are in Mexico, but it's not really like people in Mexico aren't really thinking about their flu shot anymore. It's just not really a thing so much. But the Spanish flu was all over the place. We're talking about going from Alaska. There were people on the South Pole and Antarctic stations getting sick. We're talking about Pacific Islands that had never seen the flu. And this one was scary. This was killing a lot of people. And was a really big deal. Probably this was why World War I ended, some people think. But this is an aircraft hangar, and they just set up as a makeshift hospital and just lining the people up. And the scary thing about the 1918 flu, it wasn't like typical flu that we see. Usually, some of us here might get the flu this year, and you might get sick, and you might get really sick, but it's not usually killing you. In this case, usually it's elderly people that are dying from the flu, and often it's from secondary infections such as pneumonia and stuff. This was killing young people. We're talking about like 20-year-olds getting the flu and 48 hours like dropping dead, right? So this was something new, but it was also pandemic because it was found all over the world. So what happens in 2009, we have an H1N1 flu, which is very similar to the 1918 one in some ways. And of course, people are freaking out. This is people in Mexico, where I remember there were pictures of Mexico City at the time, and the subways were empty, and people were masked and panicking because this was a new thing, right? This was early enough in the pandemic. We didn't know how serious it was going to be. Thankfully, a lot of people who got sick had mild disease. We're not talking about a lot of people dropping dead. Some people did. I remember about 1 week before the vaccine rolled out, there was a news report in Toronto about a 13-year-old hockey player. They always have to emphasize how healthy and young he was. He dropped dead, right? From getting something called the cytokine storm. We'll talk about that a little bit when we get to the immune system. But that's where the immune system just kind of goes a little, a little too excited, and lots of fluid in the lungs, probably drowned in his own fluid is what probably happened. That was about 1 week before the vaccine came out. So when the vaccine came out in Canada, the lineups were crazy. But like I said, most people were not super sick. But this was also worldwide. And also, this was showing a different pattern where you had people in tropical countries getting it, and it was spreading absolutely everywhere. A lot of countries we don't have very good data for, but a lot of countries we do, right? So pandemic worldwide. And of course, we're going through a pandemic right now. I think the Americans have declared it over, right? But in Alberta has maybe declared it over, but the World Health Organization has said it's still going on. At some point though, right? You see in the news about public health people talking about trying to treat this as endemic. I don't think we're there yet, right? There are actually more cases this year than last year. And probably way more, because how many people have gotten sick and are just stopped testing themselves, right? So we don't know the actual numbers anymore, right? I mean, look at the number of official cases. It's probably double or triple that. Who knows what the actual number is? I know lots of people who have had respiratory illnesses this fall and never bothered to get sick. They just stayed at home, and they're like, or never bothered to test themselves. They just stayed at home, and that's fine. But what the number of cases are, right? I think, too, there's all the questions about, what about the number of deaths and things like that. And this is where, at some point, we're going to have an idea what normal looks like. Just takes time, right? Whatever normal is, everyone's wondering because no one remembers anymore, right? But it's going to be the same with COVID. At some point, we're going to say there's about 10,000 cases annually in Canada and let's say 5,000 deaths, right? Let's say that's the normal. But we don't know what normal is because we're only like 2 years into this whole thing, right? So I think it's still fair to call this a pandemic, at least for a couple more years, although we are hopefully transitioning to more endemic treatment of this kind of thing, from health perspectives and things like that.
Is the H1N1 vaccination now included as part of an annual flu regimen?
Yeah, so good question. So the flu vaccine is quadrivalent nowadays, which is funny. I don't know when it switched from triple to quad. So it has 4 strains in there. 2 or 3 of them are H1N1s, right? So most of the newer flu strains, that H1N1 is ancestral to, right? Yeah, there's always different ones floating around, but many of them are H1N1. And
will that happen with COVID eventually?
Yeah, I mean, right now, so like the original strain of COVID, the alpha strain or whatever, like you don't even see that anymore. It's like 90-something% to Omicron. And so that may become the predominant strain or maybe something else eventually. It's hard to tell, right? When you look at something like flu, right? Coronaviruses actually mutate slower. They're about maybe 2.5 to 5 times slower, but with the number of infections we've seen more rapid change of the strains, right? So maybe eventually that will slow down, right? And we'll get a booster every 5 years, or who knows, right? We're still trying to sort that out. Even what's going on with immunity, there's different models, and I don't know if anybody really fully knows. Because of course, there's the question: is it our immunity is waning, or is it because we've got different strains, right? And so there's data to support both positions. And again, we're still in this stage of the many question marks. Yeah, unfortunately. But yeah, the flu is many of them, like that H1N1 is ancestral to most of the strains floating around. It kind of just took over, right? There was a point when they were doing flu testing, in 2009 and 2010, they were testing the strains, doing the genetic testing. And there was a point where they're just like, this is the only strain we're getting. So it just sort of took over, right? From whatever was floating around before. But if you do get your flu shot, and if you're really interested in these things, ask for the packet insert, right? See if you can get a copy of that, and you can see all the ingredients, and it'll tell you exactly what strains are in there. It's kind of, if you're into those things, like I am, it's an interesting read. Yeah. It's a legal requirement, though, that they have the packet insert that has all the ingredients, exactly what strains and all those kind of things. And usually you'll see it says H1N1 or whatever it is. And so I think the last one I looked at, have it in my office, I can't remember. I think 3 of them were H1N1 and 1 of them was something else, an H3 or something like that. Yeah. So what about AIDS? This is kind of interesting, let's say, flexible use of these words, because I still see people say pandemic all the time with AIDS. And there's reason for that. Generally, though, I think we're at the point now, this has been around since the 1980s. And in Canada, at least, there's kind of a predictable rate of number of new infections per year. Sometimes, it goes up and down every once in a while, with, drug use and things like that. The opioids has not helped a little bit, in particular. I don't know how much people know about the opioids. The people are getting high off them, and then they're reformulated so you can't crush them up and sort them. And so then people would melt them with the lighters, and that led to more injection use, and that actually led to a spike in HIV infections. So there's always those kind of things going on. But in Canada, we're not expecting, we kind of have an idea of what the number of new cases are going to look like. And this is true for most countries. So it's probably safe to say the accurate word for HIV infections is endemic, right? We have an idea, and some countries are much worse, right? South Africa has a lot of infections annually, but a lot doesn't mean it's anything else. If there's a predictable number of new infections, it's endemic, right? If there's a pattern that we've seen for years. That being said, we're still seeing people use the words epidemic because it sounds more dramatic, right? particularly public health experts that are working with vulnerable populations or places in the world that are, if you look at, this is showing a lot of cases for HIV are found in areas of sub-Saharan Africa, and like millions of cases, right? And the word endemic just doesn't sound strong enough. So you still see a lot of people talking about it because particularly in living memory, from the 1980s, we went to basically 0 cases to millions, right? People are still thinking of that in terms of their brain about how this is a, whatever you want to call it, a health disaster, health problem, that they would love to see the numbers go down. So like I said, you're still seeing this word. I don't think it's used necessarily accurately. That being said, with a lot of countries in sub-Saharan Africa, you do see cases a little bit more of an up and down. And kind of what you see is generally, you're looking at things like funding, you're looking at changes in government, changes in programs. There was a really good program in Uganda a number of years ago that was targeting women and educating women. And it was good, actually. The number of new cases were plummeting. There was kind of this, this slope of, and then the funding got cut, right? And the very next year it kind of spiked way up, tons and tons of new cases. So sometimes, sometimes this word is okay. I think it's overused and abused. And it doesn't necessarily, in my mind anyway, make it sound more serious. I know the number of cases are very serious and we'd like to be able to do better. But misusing the word is not always good. And same thing with the word pandemic. We're still seeing that. Multiple geographical locations are looking at having issues with the number of HIV cases. So not just sub-Saharan Africa, but you're looking at, places like Thailand who have a big sex trade industry. So, this is causing the number of cases to be, more than we would like them to see. But I think it's still an abuse of the word. Okay, so like I said, this is all about geography, has nothing to do with how serious the disease is, right? The Spanish flu was very serious, killing lots of people, H1N1. Some people got pretty sick. I don't know anybody who died of it personally, but it was a lot more mild, thankfully. Yeah, so all about geography, right? Okay, so some more definitions for you, and I want to talk about reservoirs. You may have heard sometimes people talk about communicable diseases versus non-communicable diseases. So communicable means contagious, meaning you're getting it from another host. So it could be another human, could be another animal, right? That's generally the case. Non-communicable, most people, when they say that, they're thinking of chronic lifestyle type diseases. So cancers, you got cancer because you've been smoking for 50 years, or you have heart disease because of your bad eating habits, poutine, breakfast, lunch, and dinner for 20 years, that kind of thing. But it doesn't necessarily mean that, right? It can mean diseases that are not caught from another host. And for microbiology, there's kind of 2 scenarios that I'll give you that are kind of a good place to look, right? One is you're getting the disease from your own flora. So maybe you have staphylococcus on your skin, and you get a scratch, and it introduces it deeper into your tissues, and now you have some sort of staph infection. Or sometimes people get bladder infections. You have E. coli is in your intestine, and it ends up in your urethra, and you end up with a bladder infection. So that is a case where your normal flora is making you sick. Another case is where we get microbes from non-living things. So usually we're talking about soil. Clostridium botulinum, which causes botulism, and Clostridium tetani, which causes tetanus, are 2 good examples of that, of organisms that are living in the soil, and you can get from these other things. So let's talk about reservoirs and give you lots of examples of these. So I just gave you some examples of the normal flora, right? So one more example, yeast infections. So yeast is part of the normal flora. It's found on the skin, a lot of mucosal areas. I think the example I gave you last week was the case where some women might get vaginal yeast infections from getting antibiotics. So by antibiotics, I mean things that are killing bacteria. So the bacteria get wiped out from your normal flora, and the yeast have a chance to thrive and grow, and then they're causing, an infection. So that's another example. So by the way, I think it was last year, or was it previous year? I can't remember. On the final exam, right? I had a question that said, name the 4 sources of pathogens. Okay, and I meant reservoirs, and people were all over the map, right? There were lots of weird answers. Okay, but by reservoir, I mean the source of the microorganism. That's where it is living normally, right? Okay, and so there's 4 categories. Number 2 is human carriers. These are the ones probably more people are familiar with, the things you're getting from somebody else, right? Somebody has a cold and they sneeze on you, and now you have a cold, right? Someone has a strep throat and you share the toothbrush with them. Don't share your toothbrush. Please don't. Okay. Infectious mononucleosis you get from mucus from other people. Sexually transmitted diseases you're getting from other people, right? So gonorrhea, syphilis, etc. So human carriers are usually the easy ones to understand. Lots of examples people are familiar with. Number 3 are zoonoses. And these are from animals. So we defined that already. I actually have a whole bunch here. I'll show you. Found these nice tables here. And some that you may not necessarily be thinking about as zoonotic diseases, right? So influenza can be from a human carrier if you're getting normal seasonal flu, but there are sometimes cases where people get flu from other animals. So we've got avian flu from birds or swine flu from pigs. That's why it says some types, right? So that is possible. Most of us here are probably not farmers, so that's not that common for us to get those types of influenza. But if you are a farmer, it might be more likely. West Nile virus. It is a bird thing. We are not the normal host for that virus. So this is a bird thing, and it's spread by mosquitoes. So it's not usually spread from human to human. Usually the mosquito bites the bird and then it bites the human, right? Sometimes it has been transmitted by blood transfusion, but that's not the normal scenario. It's from a bird, right? Bacterial, we talked about anthrax a little bit. Usually you're looking at contact with animals. Sometimes it's soil. So this could fit into that other category as well. Plague, right, we talked about is from usually rodents is the natural reservoir. Salmonella, it's birds and reptiles. So if you have a pet bird or a pet reptile, anyone have a pet snake or a turtle? Nobody has a pet turtle. Usually there's somebody who gets suckered in as a kid. You buy you talk to your parents and getting the turtle and you're like 10 years old. And then you find out that turtle might live 50 years, right? I have a friend, she's about 50 and she's got about 3 turtles she bought when she was 19. And she's like, I don't know when these things are going to die, but I got them. She has them forever, right? So wash your hands, right? If you're playing around with your friend's snake or turtle or something like that, wash your hands afterwards. Salmonella is part of their, it's found in their feces. And it's going to be on their skin and you can get sick from that. Lyme disease, normally the reservoir is actually mice, okay? Not deer. We'll talk about Lyme disease, maybe not today. I'm not sure if we'll get there, but it's actually a type of mice. A few more, right? Fungal, so ringworm we talked about is a fungal infection, pretty commonly found on animals, can be transmitted human as well. Protozoan, African sleeping sickness, one of the ones we talked about as well. The reservoir is wild and livestock animals, right? And spread by fly and pork tapeworm, which is, I don't know, it's on this list, right? We're getting it from an animal, but humans are an essential part of the life cycle too, but you're technically getting it from the animal in most cases. Last category, abiotic. So I mentioned the Clostridium, so tetanus and botulism are good examples of that, of soil organisms. So you're not getting it from another host. I think I've got a slide here on botulism. Botulism is not that common. I was looking it up. Here's the data for botulism. So an average of 1 case in Alberta per year, right? So every once in a while there is an outbreak. And every once in a while, I get people asking me about this, because if you've ever had a baby, you'll see that in a lot of the baby literature, it says, do not feed your infant what? Anyone know? Honey. Yeah. So it is possible that honey can have the endospores from botulism. Right? I think I was reading the stat. It's about 1 in 20 batches of honey. Honey is not usually pasteurized. And it's very, very small amounts. So it's not, you know, if you're over like 1 year old, it's not really a big deal. You're not going to get sick. Your body can handle it. But an infant, a baby, you know, the immune system is it's just getting started. It's not ready to go and do things yet, and it can be lethal. But the stats are, you know, I was trying to find out how many babies died of botulism in Canada in the last 50 years. I could not find a number for it. Just lots of warnings that it might happen. So if you accidentally give your baby honey, it's probably okay, but I don't recommend it just in case. Where do people get botulism from? Sometimes there are outbreaks. There was an outbreak in Alaska. Trying to remember what year that was. I think this was a few decades ago. With some not very good canning practices that were going on. But sometimes this happens. People do canning, you know, they have their foods and they, you know, put them in the jars. I'm not exactly sure. So it actually says here low acid content. So these are some of the more common foods that might actually cultivate botulism. The endospores, you know, when you cook the food to put it in the can, the endospores survive. And so, you know, if you do any canning, always a good idea to open that up. And when you do, give it a sniff, take a look for anything black. Black could indicate growth of the bacterium. But like I said, you know, number of cases, I don't know what's going on in 2021, but an average of 1 in Alberta here. That's what I'm wondering. Yeah. Yeah, probably people were like in 2020 were like, yeah, I saw my grandma do this years ago. Don't really know what I'm doing, but I'll just do it, you know. People were making lots of weird things, right? In the kitchens. I mean, the worst part was I make my own pizza all the time and suddenly you can't buy yeast anymore, right? You know, because everyone's making bread. I'm like, come on, you know, save me some for my pizza. I'll be happy. Okay, so that's reservoirs, right? So 4 categories. Everyone on the final exams are going to be able to list all 4 categories and give me one example, right?
Yes.
Okay, good. I don't know if that's a hint or a promise. I don't know what it is yet. Haven't written the final exam. But you can star it and write it down. Yes. Okay, so let's talk a little bit about modes of transmission here. I'm going to give you a few different categories. And this is one of these things, every time there's a new outbreak, I see people freak out about certain things and then they're using words they don't really fully understand. So it's kind of worth it to kind of go through these and talk about what they mean. And it also is important to understand how the transmission of these things work, right? So category 1 is contact. Hopefully that one is kind of obvious what it is. The first is direct contact. Okay, so here's my joke of the day, right? We've got handshakes, kisses, sexuals, and bites. My joke is that's not a progression. That's just a list. That's just a list, okay? But bites, right, like rabies, okay, that's what we're thinking about. But any of these kind of things. So you're directly touching somebody and you're getting it from them, right? Kind of related is indirect. So some sort of fomite, right? So, you know, I keep pointing at the doorknob. You know, somebody sneezes on their hand and touches the doorknob. I remember when I was a student one time on the bus and I saw somebody this time of year sneeze in their hand and they grab the pole and I see them sort of slip as they're grabbing the pole. And I'm just like, I don't want to touch that pole, right? No. So anything that is inanimate is something called a fomite. So sometimes you're sharing things, water bottles, toothbrushes, don't share toothbrushes. But bedding towels, you can imagine, huge list of things, gowns in clothing in hospitals and things like that. I guess some examples, right? Direct contact, right? Anything that's sexually transmitted, a lot of respiratory infections by mucus, and many of the same examples here, but not necessarily crossing over, right? You're not going to get any sexually transmitted diseases by sharing a toothbrush, right? But you can get respiratory diseases this way as well. Staphylococcus, right? Spread this way in hospitals. Clostridium difficile as well. Like I said, sometimes when people have these things, a lot of hospitals have protocols now for hand washing around these patients, and guests have to, gown up and so those kind of things to try to prevent the spread, across the hospital to new patients. So respiratory droplet, right? So this is what we were talking about a lot with COVID-19. Okay, and I'll get into this in a second, but this is basically when you sneeze or cough or something like that, you've got moisture coming out of here, right? So notice this, it says about 1 meter. So this is for like the person with the average size nose. So believe it or not, there's studies that show people with bigger noses can sneeze slightly further, right? So everyone's looking around and sizing everyone else's nose up, right? But okay, so 1 meter. Remember during COVID, there's that whole thing about, the distancing, right? So, they say 6 feet, which is 1.5 meters, kind of to give a little extra space on there, right? So, but there are lots of studies like this that done, and you can see this is just gravity. So it's kind of like if you can imagine if I had like a ball here, let's say a soccer ball, and I toss it to you, it's just gonna, gravity is gonna bring it down. So this is all just physics, right? So this is why they're saying, that physical distancing they're recommending, right? You can see all these notes from historical epidemics and pandemics where they're recommending some of the same things. Thought I had my COVID slides here. I'll get back to her in a second. Don't worry. Oh, where's my COVID? I gotta find my COVID slides. But there is a Kahoot coming up in a minute, so I will just give me a second here. I got some COVID slides. Here we go. So I was going to show you this, and we'll come back to these other methods in a minute, right? But in terms of what the data is looking like with COVID, I was trying to find some actual numbers here. It's really hard to get these kind of numbers because most people are not necessarily knowing where they got it from and exactly how they interacted with the individual they got it from, right? But they think it's about 80%, maybe here, or sorry, 60% here, 20% here. The aerosols, we're going to talk about shortly. They think maybe about 10% of cases, but we're not really sure. Probably most cases are kind of in this category here.
Is this in the slide deck you have? Or?
Yeah, so this is just a little bit later, because I haven't talked about aerosols yet. Okay, so let me just go back up there. Where were we here? Just before the Kahoot. Okay. All right, so one little story, and then we'll do the Kahoot. So let's talk about Typhoid Mary. All right, she probably doesn't want to be called that. This is her real name, Mary Malone. So this is kind of an interesting case. This is the 1800s, I think the 1880s. I'm trying to remember the exact date. So she was an Irish immigrant to the United States, and she was a cook. And there was this outbreak of salmonella. And we're talking about an outbreak, like 3,000 people were getting sick. I think a couple people died from it. And they're trying to figure out, okay, what's going on? And they sort of, these epidemiologists, they do their investigations and they kind of narrow it down to a group of cooks. They watch for more cases and they figure out, she seems to be the common thing. What's going on, right? So they show up at the door with their official looking suits. She looks out the window and runs out the back. I kid you not, right? And they cook somewhere else, uses a different last name, a fake last name, does some more cooking. Eventually they catch her and figure out that she is giving people salmonella. And she's like, I'm not giving people salmonella. Typhoid fever, right, was the disease. I'm not sick, right? I'm fine. Anyway, it was just kind of this interesting scenario where they told her, okay, fine, just you can't cook anymore. And so she did some other jobs, they didn't pay as well. She started cooking again, and they eventually had to arrest her and put her in this sanatorium. and where she lived out the rest of her days, not being sick, being really grumpy, and those kind of things. And so what was going on here, right? So she was kind of this interesting case of what we call an asymptomatic carrier. And this is something we've seen with COVID. Some people are probably asymptomatic, meaning they have the pathogen. They're not having any symptoms, but they're still able to pass it to other people. So she had it in her gut. She was probably not washing her hands sufficiently and giving to other people, right? So this is direct contact, or sometimes we might call it foodborne as well. But let's do that Kahoot, okay? Okay. So funny story about this Kahoot. I was like, okay, we got to do a Kahoot today. We got to do about halfway. I'm thinking about planning the timing of it to give people a little mental break. And then today, like I kid you not, around 11:30, I'm like, I don't have a Kahoot. So I had to quickly slap this one together. So it might be easier than some of the other ones because I was just kind of making them really quick. Oh, is this new, eh?
Yeah.
Okay. Well, some of you guys are really scary looking. Okay, let's do this here. All right, number one, which of the following infections is endemic to Canada? All right, correct answer is influenza. So you got to remember what endemic means. It means happens here normally and naturally. Okay. Okay. True or false? Epidemic means a worldwide outbreak. Answer is false. So epidemic usually means certain locations. So with COVID-19, there was a point where it was not necessarily found everywhere. There were cases going on in China and Italy and the World Health Organization. There was a certain point where they declared it pandemic because it wasn't pandemic until it was found in multiple continents and all that. Okay, changing things up here. True or false? The reservoir refers to the natural host habitat of the organism or the source of the pathogen. It's a nice reservoir. So close. So close. One of these days we're getting 100%, right? One of these days. Okay, good job, Yui. All right, number 4. Which of the following is not a zoonosis? All right, correct answer is gonorrhea. So I hope not. Hopefully that's not always the answer. Okay, we're gonna be on a hot streak there. Okay, number 5, a fomite is an inanimate object that may carry a pathogen. All right, I made these ones too easy, didn't I? It's okay, we gotta boost your confidence once in a while, right? Okay, so close. Okay, oh boy, the number 1 spot, right? Fighting for it. Botulism. 4 options. I had to throw one hard one in there. Okay. This is the correct answer. First comes from the soil. It does not come from another host. Okay. Bronze for me. Silver for Andy. And gold. Who's it gonna be? Huey. Okay, well done. Here we go.
Speed.
Okay. So moving on, I want to talk about some other types, right? So contact transmission, most people kind of understand that. There is going to be a distinction between droplet and airborne. I'll get to that in a minute here. The vehicle, right? So water, food, and air, right? Things we're exposed to kind of constantly. Water and food are kind of very similarly related because we're consuming them. And in many cases, water and foodborne infections, we're really talking about human or animal feces. That's what usually the contamination is in many cases. Lots of examples here. Waterborne diseases, there's thousands of cases per year annually in Canada. Most people aren't getting severely ill, but for the most part, we have water treatment in most places in Canada. So you're looking at people that may be going camping once in a while. There are sometimes outbreaks that are, due to contaminated drinking sources. There are a lot of remote and indigenous communities that don't have proper water treatment. There's all sorts of examples of where that happens. Examples are things like traveler's diarrhea, which is often pathogenic E. coli. We talked about Giardia. And a bunch of others. I think I actually have a list here of waterborne diseases. Let me see here. Oh yeah, I do. Okay, here's a whole list, right? The ones in bold, right, are the ones that are examples in this class. So you can see we're obviously not covering everything. So we talked about E. coli. We talked about, actually, I'm going to talk about Legionella here in a moment. Salmonella, cholera. We talked about Entamoeba histolytica, Cryptosporidium, Toxoplasma. These worms, not worried about them in Canada, and various viruses, right? So hepatitis A, every once in a while there's an outbreak in Canada. It's usually more associated with the food than the water in Canada. I'm trying to remember, there was an outbreak in Toronto a while ago. I think it was onions, right? So it was like one restaurant had some contaminated onions, that kind of thing, and so on, right? Let's talk about Legionella for a minute here. If you take a look at causes of waterborne disease outbreaks, so this is US numbers, but Canada is pretty similar. So you can see kind of this pie here. It's kind of like everything else, and Legionella is half, right? So this is kind of a weird thing, because I was just telling you that we're usually looking at fecal matter is being the source of a lot of these pathogens. Legionella is kind of the exception. And as a consequence, we're looking at different symptoms. I'll talk about Legionella in a second. I'll show you a cool picture in a moment. But most gastrointestinal kind of waterborne infections, we're looking at the usual things: diarrhea and vomiting and related symptoms. So sometimes cramps and things like that, right? Sometimes you're looking at other symptoms depending on the virus, but diarrhea and vomiting because it's going through your gut and cleaning things out. Legionella is actually a respiratory infection. So it's kind of important to talk about that since it's about half the pie. And we're looking at a different kind of scenario. So what is that scenario? It's looking up for pictures of hot tubs. And I saw this. Has anyone done this? No, yes.
I've seen it. I haven't done it, but I saw someone.
Yeah, I was like,
Big
this is
Valley.
yeah, I'm sure so. I figured somebody's done it. Looks like fun. I mean, you know, I don't know, you got a truck, might as well put it to use if you're not bringing it off road, right? Anyway, so what is Legionella? Legionella is an environmental pathogen and it likes to grow in warm water. So think about all of the human things that may include warm water. So you've got hot tubs. I'm not really sure how air conditioning units work, but for large buildings, they often have these cooling towers on the roof where there's warm water that pools. I don't really know too much about the engineering of these things, but these are breeding places for Legionella and anything that produces a mist, right? So it's going to get into the air. People are going to breathe it in and then they get a respiratory infection. So sometimes it's called Pontiac fever. I have no idea if that's a Pontiac or where that word comes from, but you're looking at pneumonia with a fever. And it's caused by Legionella. So, you know, it's my note, not drinking water, but this is moist droplets that have some place of culture of this bacterium. So you're looking at, like I said, hot tubs is a big one. People just not monitoring the chemicals properly. And of course, it's causing mists and things like that. I meant to look up the number of cases in Canada per year. It's not a ton. Every once in a while, there is an outbreak. There was an outbreak in Los Angeles a number of years ago. I was just mentioning one of these cooling towers. And it was breeding Legionella somehow. It was going through the ventilation system of this apartment building. And so there was this outbreak of like 100 people getting sick. So that kind of thing does happen once in a while. I think I have a picture of it. There it is. Kind of just looks a little bit like E. coli. Biologically a little bit different, but you can see the normal symptoms of pneumonia. So cough, chest discomfort, and of course the fever in there is in there as well. And sometimes this is called Legionnaire's disease. So I did mention this bacterium way back at the beginning when we were talking about naming of things. This was discovered at a Legionnaire's convention. So Legionnaires are people that used to serve in the military, right? They're, you know, they belong to the Legion or whatever, and they're having some convention or meeting. And it went through the ventilation system. A bunch of people got sick, and then initially they called it Legionnaire's disease and named the bacterium that was discovered Legionella. So kind of a interesting story behind that one. So what about foodborne? So like I said, you're looking at some of the same pathogens because food and water are often interlinked. But in many cases, you're also looking at kind of some unique areas. So ground beef, for example, is something that can get contaminated very easily because you're mashing it up in a grinder. There's potential to introduce things to it. These are apparently the top 5 in Canada, according to public health. You can see the number of estimated cases. Norovirus, maybe 1 million cases. We don't know. Most norovirus cases do not go to the clinic or the hospital. We'll talk about norovirus a little bit later on. I affectionately call this one the 2-bucket flu. I'm seeing some people, the lights are going on, you know, so we're talking about vomiting and diarrhea, right? If you didn't get that, okay. And violent, right? We're talking about 1 day of being violently sick, right? So most people get this every few years, right? And it's, you know, you got a nasty 4 to 24 hours kind of thing, right? For most people. Some people it's a little longer. Not so many hospitalization deaths are very rare from it. Norovirus is often associated with daycares and nursing homes and cruise ships, but you know what, everyone gets it once in a while. It's you don't want it. It's no fun. The other ones here, listeria, we talked about that one as being associated sometimes with pre-packaged foods. This is the one that grows really well in the fridge and sometimes is with lunch meat recalls. Salmonella, we were just talking about a minute ago. We'll talk about E. coli 0157 soon. This is the bad pathogenic E. coli the really nasty one that makes the headlines. And Campylobacter, we don't really talk about in this course, but you know, it's a common cause of food poisoning or whatever you want to call it, food illness. Kind of associated with salmonella, comes from fecal matter, similar symptoms. So it's not worth, you know, going through every example. But you can see the number of cases and always a few deaths annually too. But some people get very, very sick, of course. So where are we getting it from? Right? All our food. If you're vegan, you're not safe. Sorry. You can get it from all sorts of things, right? Salmonella, often associated with poultry products, right? But these organisms, you know, they can contaminate almost anything, kind of depending on the scenario. I think I mentioned the romaine lettuce before. Recall that was maybe 4 years ago. It was a massive, like, recall across North America, and it lasted for months. And it was just from flooding, going from one farm and flooding manure into these massive lettuce fields. And it just took them a long time to figure out where the contamination occurred. But anyway, that's one study. I keep seeing different studies that are showing different, you know, sizes of the pies. But anyway, I thought I'd show you that one study. Okay, so what about airborne, right? I was just mentioning the respiratory droplets. So if I were to sneeze here, you're probably okay, right? Depending on how big my nose actually is, right? So, but if airborne is a little different. So I mentioned, like, if I were to toss a ball at you, gravity would bring it down, right? And with further force, I can maybe get a little further, right? That's why people with bigger noses tend to go a little further. Pigs, by the way, up to 5 meters. That's how far the respiratory droplets can go. Some of these pigs, they've got big noses, right? There's studies done on these things. Airborne's a little different. So airborne means that if I were to exhale something airborne, it's going to float around, and it can last 2-3 hours. So I could be breathing in this room. If I had measles, breathing in this room, leave the room, someone comes back 2 hours later and gets measles. So it's a little bit more like if I had a bubble wand. I could blow that, you can imagine the bubbles kind of going around, except for they're really stable bubbles that last, you know, depending on the pathogen. Some don't last 2 hours in the wild, but that's kind of different. So it could go through the ventilation, right? So I could be breathing in this room, get sucked up in a vent somewhere, I don't see any vents, and then goes into the next room, right? So this is kind of worst case scenario for some things. And I know some people are arguing that probably some cases of COVID were probably airborne, because there were some people that just never went out and never had contact with people and are trying to figure out where they got it from. But again, sometimes it's hard to tell unless you can do the studies in animals sometimes, and that's where we can learn these things. So here's some examples of some diseases. Often we're looking at viruses and very tiny things, but there have been studies with tuberculosis. I was actually looking that one up because sort of the logic is that it's too big to be spread that way. But I was reading about this one study done in guinea pigs where they literally did that, where they had some in a cage in one room, they had a vent, and then some in a cage in another room, and those ones in the other room did eventually get sick. It's pretty rare, but it can happen. Usually tuberculosis, you're looking at close contact with someone who's sick and prolonged exposure. So if they cough or sneeze on you once, that's not usually a big deal. Well, it is. If someone did that to me, I wouldn't be happy. But you usually have to have repeated exposure to get tuberculosis. Endospores are a little smaller, right? So that's also aerosol, and you're looking at all sorts of viruses, particularly the small ones. That's one reason why influenza spreads a little better, by the way, in the winter, is it can go from respiratory droplets to actually airborne, right? So in the winter, things are drier, and the virus can actually get on dust particles, but the moisture needs to be dried up, or else the dust particles, they sink to the ground because of gravity, and then they can float around a little bit, right? And so that's why there's a bit more transmission of influenza in the cooler weather.
So chickenpox is spread through airborne?
Yes,
Not touch.
that's right. Yeah, both. Yeah. There's viruses in the pustules, but it does get exhaled too. It goes to the respiratory system. Yeah, that's why when there's an outbreak, in a school, it's very important, they figure out who's vaccinated, who's not, because everybody in the school has a potential of getting it, right?
Your parents just rub you together so you get it at the same
Yeah,
time.
that's what they used to do. Yeah, we'll talk about that one too.
Yeah.
Yeah, so here we are back to COVID. Some people are estimating 10%. Some people say it's a lot less. There's a little bit of debate over that, but it doesn't really matter. I mean, people are getting sick, right? It's not much you can do about aerosol transmission, right? Other than not have people around, if there's no vaccine or something like that. This is why they had all these graphics like this to try to show you what 2 meters look like. Like I said, 1 meter is the zone, 2 meters is the safe zone, right? So, and anyway, all these cute graphics. Okay, so water and food, we're usually talking about fecal transmission. Kind of the big exception is Legionella, which is kind of a bit more common in countries like Canada where we have water treatment, and so the other waterborne and foodborne diseases are more minimal. Foodborne, right? You're looking at food practices and treatment and cooking your meat and all that. Believe it or not, a lot of more foodborne illness is what happens at the home than what happens at the grocery store or the farmer or other levels, right? It's practices that people have at home that are more likely to make them sick. So people that are, the meat is way beyond its expiry date, or they're not cooking it properly, or all sorts of things like that. So that's kind of just a little fact for you. Airborne, like I said, you're looking at being able to float through the air. Does not include most things, but is a concern with some things. Okay, where are we with time? All right, just enough time to kind of talk about these. I don't know if we'll kind of get probably save. I'm not sure if we'll get into Lyme disease or not. But let's talk about vector. Okay, so vector usually means some sort of arthropod. And when we mean arthropod, right, we mean insects, ticks, and a few other things, right? So an insect has how many legs? Six, and a tick has 8. So just, if you don't know, there is a difference, right? They are fall under the creepy crawly thing. So mechanical transmission means that you've got some sort of insect that is not really essential for the transmission of the disease, but it happens. So this is usually more of a sanitary situation, right? So you can imagine where you have, let's say a cockroach crawls across some fecal matter and then crawls onto your sandwich, right? This is the kind of thing that's going on. You can see they're being a little bit more nice here. You can see the bug landed on the poop over there, landed on the guy's hamburger, and then he gets sick. So this happens. This is more of a, like I said, you've got anywhere where sanitation is a problem. This is more common because it's just kind of a probability thing. If you have, some filth and you have lots of insects, and eventually one of them is going to land on the poop and then eventually land on your food, right? So this is one case. This is mechanical. Yeah. So what's biological then? Biological means the vector is essential for the transmission of the disease. In some cases like malaria, the vector, the mosquito, is part of the pathogen's life cycle, right? So the vector is kind of essential. Now, a lot of these diseases, you could get them without the vector, but those usually are rare circumstances. I mentioned West Nile virus and transfusions, right? Most people are not getting it that way. Most people are getting it from a mosquito bite. So let's take a look at some of these. This is not the complete list of vector-borne diseases. There's a huge list of vector-borne diseases. Now, what did I do here? I tried to, I meant to bold all the ones we talked about. I didn't get that far, but I did put the ones in red. Red is for anyone? Canada. Yay, right? So this is the good news. There's very few on this list, right? There's actually a few others on the list for Canada, but we're looking at like 0 to 1 cases per year for many of them, right? In fact, rickettsia, the Rocky Mountain spotted fever, I think the average is like 5 cases a year for Canada. So I will never mention it again because it's, I'm only going to talk about Lyme disease and West Nile fever. But it's very rare. It does happen, and it's kind of usually west of the Rockies. So we're east of the Rockies, so we're all good, right? Many of these are tropical diseases, but not necessarily the case. but you can see we're looking at all sorts of different arthropods. So let's take a look. A few minutes, I'll talk about Lyme disease, and I'll come back and talk about it again next day in more detail. So here are some of the vectors. We've talked about some of these ones already. Lice we talked about as being their own infection, but in some cases they can transmit certain fevers and things like that. I'm not too familiar with lice transmitted diseases because it's very rare in Canada. I don't know if it ever happens in Canada. But the big ones are the mosquitoes. Probably transmit more infectious diseases than any other method on the planet, right? The reduvid bugs, the kissing bugs, so Chagas disease, mites in some cases, ticks are the big one, and of course flies, right? Okay, so let's just talk about Lyme disease for a minute, and I'll come back to it and talk about it again next day. So Lyme disease is in Canada, and it is spread by a tick. It's actually spread by 2 species of ticks. These are the names. Usually it's called the black-legged tick. Sometimes this is the black-legged tick. Sometimes called the deer tick. I've also heard it called a Lyme tick. I've also heard it called a bear tick. Apparently in Montana, they call it the bear tick. But that's what it looks like. And it's very, very, very tiny. This is a Canadian dime. And the one that we need to be most concerned about is the nymph stage. So you can see the nymph stage is about the size of a poppy seed. So if you have a tick on you and it's not the size of a poppy seed, it's much bigger, don't panic. Okay, yes, it's a blood-sucking parasite and it sucks to have that thing on you or your dog, but just pick it off and there's probably no risk of disease. If it's bigger than a nymph, and it's red, you can take a picture of it. There are apps now. Use places where you can send in the pictures. Keep the tick if you're concerned, and they can send it in and always check it out, right? Because I do want you to get treated if you get exposed to Lyme disease. West of the Rockies, there's a closely related tick called the Western black-legged tick, and that's found west of the Rockies. Also spreads Lyme disease. Okay, a couple other things I'll say about this before I let you go. Just wondering what my next slide is. There it is. This is where I wanted to finish. I really did. So who likes poppy seed muffins, right? Oh boy, yeah. So the CDC put this on the internet a few years ago, and boy, did they have a lot of complaints.
I see them.
Right? Can you see them? Yeah. There they are. All right, so a couple more things about this. This is caused by a spiral-shaped bacterium. And the good news is for all of us in Alberta is historically, we don't think there's been a single case given to an Albertan in Alberta. There's always a few cases every year in Alberta, but at the moment we seem to attract them to other places. So people visiting other places. So that's the good news. The bad news is the ticks are here. We do find a few of them every year. Historically, I think there have been a total of 3 ever found in Fort McMurray on dogs. So that's the bad news. It's coming. So lots to say about Lyme disease next day. I'll let you go. I think at least half the birds are full, so we'll finish it there. Okay.